Okay, so in this theorem in circle geometry, we're going to be focusing on finding the internal angles. Okay, here, this is actually internal angles given the size of your arc, two arcs intercepted by these two intersecting chords. Okay, so the formula for that is you're going to be the size of the angle in the middle or inside is actually 1/2 of the sum of the arc x and arc y. Okay, so let's not forget this one. And on the other side, this is a theorem where you can see that there is an external angle, okay, and you have intercepted arc, okay, big one and small one, big one and small one, and you have the angle in here, external angle plus, and then the arc and a bigger arc again. So our formula for that is simple. Okay, so the size of any angle in here, outside angle, is going to be 1/2 of the bigger angle. This is your larger angle, yeah, sorry, larger arc, and this is your smaller arc. Okay, so I hope you will not forget that. So we're going to look at just two examples in here for us to understand clearly. Okay, so here are the examples here. So if we are going to look at this one, this is actually going to fall under our first theorem. That's going to be the internal angles. Okay, so for internal angles, what are we going to do with that? Okay, so it says that the internal angle, okay, the internal angle x in this case is going to be 1/2 of x plus y. So let's assign x and y. Let's assign that, and this is going to be y. So we're going to now find it. Let's compute that one. So the measurement of angle x is going to be 1/2 of our x is 46 plus 90. So that's going to give 46 plus 90 is going to give you 136. Yeah, so 1/2 of 136 is going to give you 68. Okay, so as easy as that. Okay, yeah, as simple as that. Okay, so here in this case, we're going to be looking at this theorem in here in 1214. Okay, so how does it look like to me? So anything is, it looks like a tangent. Okay, this one, it's case number 2, formed by a secant and a tangent. Okay, so still our angle in here. Okay, so our formula is still the measurement of angle 1. Let's say this is the angle 1. Okay, let's just call that an angle 1. Angle 1. And we're going to measure, say that x and y and z is going to be 1/2 of x minus z. Okay, so in this case, the angle as is already been given. So let's just plug that into our formula. Okay, so the measurement of the external angle here is 20 degrees is equal to 1/2 of 95, which is 95. Okay, there. And we don't know this one. Okay, so just leave it as z. Okay, so for you to fully understand, all numbers have a denominator of 1. So it's just like this one, 20 over 1, and this is going to be, this can also be written as, let's say, 1 times 95 over z divided by 2, something like this. Okay, so what I do is I'm going to cross multiply that, so it's going to give you 20 times 2, yeah, 20 times 2 is equal to 1 times 95 minus z. So that's how it looks like. So simplifying it, it's going to give you 20 times 2 is going to give you 40 is equal to 95 minus z. Okay, getting the hang of it? Okay, so what will happen now here is I'm going to put this on the other side. Okay, or we can also put this negative z on the other side and put that on the other side. We can do that. Okay, so what I will do is what I suggested. So I'm going to put negative z on this side, so it's going to become positive. This will remain 95. and then this one is going to be going back on the other side, so it's going to be minus 40. So z is equal to 95 minus 40. Okay, so you know that 95 minus 40 is 55, right? That is 55. Okay, so the size of our z in here is 55. Now let's recheck. We have a recheck here. Recheck. So the angle given is 20. 20, is it equal to 1/2 of our x is 95 minus 55? Yeah, so 20 is equal to 1/2 of, okay, we know that 95 minus 55 is 40, just like this one. Okay, is 40, and 20, what is 1/2 of 40? That's going to give you 20, therefore it's correct. Okay, so that's as simple as that. I hope you understand this very well. Thank you.